Alright guys, this is chapter 6, lesson 3, algebraic relationships, equations. Our TEEX, which is our objective, is 6.6b. I can write an equation that represents the relationship between independent and dependent quantities. Okay, so we're going to start with some vocabulary. Our vocabulary term for this lesson is a linear relationship. Okay, so it's kind of highlighted here. It's a little dark, so go ahead and let's underline it. A linear relationship is an algebraic relationship whose graph is a line. Okay, well, what does the word linear mean? Linear means having the form of or resembling a line. Okay, so it either forms a line or it looks like a line. Okay. What are we talking about when we say the word relationship? Well, a relationship can mean that we have a connection. When I think relationship, I also think maybe association. So how are we associated or connected to another person? Okay. It could also mean involvement. Okay, if you're involved, like if you have a relationship, maybe a friendship with somebody, okay, that would be an involvement with that person. Okay, so let's look at this graph. Okay, this graph represents a linear relationship, and what do you notice about it? Okay, well, it forms a line. Okay. So we've defined linear, we've defined an everyday definition of relationship, but what would be a math definition of relationship? Okay, well in math, when we're talking about relationship, it means being connected or related by input and output values. Okay, so going back to what we've been talking about in class with our independent and dependent quantities, okay, we know our input is our independent and our output is dependent. So when we're talking about relationship in math terms, we're talking about our input and outputs being connected and related. Okay, what do they create? Okay, just a little reminder. When we have ordered pairs, okay, we know in our ordered pairs that our x is first and our y comes second. Okay, and we also know our independent quantity is our x because of our mix dry or our dry mix. Okay, and that the mix is telling us that the independent is our x and it goes on the x-axis. The dependent is the y and it goes on the y-axis. Okay, and we've already learned our terms for independent and dependent quantities. Independent is the quantity in a relationship with a value that is subject to choice, meaning it can be any number that we choose. But the dependent is the variable in a relation with a value that depends on the value of the independent quantity, meaning whatever number are dependent in, it depends on our independent. All right, let's look at number 1. The table shows the amount of money Carly earns based on the number of hours she babysits. Write a sentence that describes the relationship between the number of hours she babysits and her earnings. Okay, so let's look at our table. We know that we're either going to have a multiplicative or an additive relationship, meaning we're either going to be adding to go from x to y or we're going to be multiplying. Well, I know to go from 1 to 6, we could do 1 plus 5, but if that's our rule, it would have to work on every one. Well, I know 2 plus 5 is 7, so that we can't be adding. That means that we need to multiply. Well, 1 times 6 does give me 6. Okay, 2 times 6, 12. Yep, it matches. Okay, so our rule is that we are multiplying by 6. Okay, we're also going to write our rule above our table. So this is our input, which is our x. We're multiplying our x by 6 to equal our output, which is our y. Okay, well, what's the relationship shown? Well, for every hour that she babysits, how much is she earning? $6. Okay, so we know that she earns $6 for every hour she babysits. Okay, let's look at the next example. Number 2, it says write an equation to represent the relationship between the independent and dependent quantities shown in the table. So our input, which is our x, and then our output, okay? And they actually even told us what it is, what the relationship is. What we're doing is we're multiplying by 9, so it should work on each one. Okay, and I apologize this didn't come out very well. So give me 1 second. So you might need to take your pencil and retrace some of these numbers. Okay, this is a 9. This is 18, 27, 36, and 45. Okay, and what are we doing? Well, we're multiplying by 9. So the relationship is our input multiplied by 9 equals our output. Okay, so algebraically, if we wanted to use our variables, my input x times 9 is going to equal my output y. Let's look at the next example. Next, we're going to represent the relationship y equals 2 times x with a graph. Okay, and what they did was they gave us a table, and we're going to use the input and output values that they gave us to write our ordered pairs. Okay, so they told us that we're going to multiply our x by 2 to equal our y. Okay, so that means that this is going to be 2 times 0, which equals 0. 2 times 1 equals 2. 2 times 2 equals 4. Okay, well, what are our ordered pairs? Our x comes first, 0, and then our y. This one is 1 and then 2. This one is 2 and then 4. Okay, and we're going to represent this on our graph. We know that on our x-axis is going to be our independent quantities, and our y-axis is going to be our dependent. We're going to walk before we fly. So my first one is 0 and 0, so we're just going to stay right at our origin. Next we need to walk to 1, fly up to 2. Then we're going to walk to 2, fly up to 4. Okay, and what do you notice about the relationship? What does it create? It creates a line. So we created a linear relationship. Okay, last example. Martino constructed the graph shown, which shows the height of his cactus after several weeks of growth. Represent the relationship with a table. Okay, so again, we have a linear relationship. Okay, and they actually gave us ordered pairs. We just need to make them a little bit darker. There's this one. Okay, so we need to find our x first, which is our 1. Our y is 2. Next we have 2. We walked to 2, flew up to 4. Then we walked to 3 and flew up to 6. Okay, so all we did was we took the ordered pairs from our line and filled out our table. Last, it says write an equation from the graph that could be used to find the height y of the cactus after x weeks. So they're asking us to identify our pattern again. How are we going from x to y? Okay, well, I know 1 plus 1 will give me 2, but 2 plus 1 gives me 3, so that can't be our relationship. Well, what about 1 times 2? 1 times 2 is 2, that works. 2 times 2 is 4, 3 times 2 is 6. Okay, so we found our rule. We're saying that we're taking our x times 2 to equal our y. Okay. And it also shows that we're increasing by 2 each time. So our equation, we already wrote it one way. It can be x times 2 equals y. Or if we want to show it correctly algebraically, we also know that when you have your number and a variable right next to each other, that also means multiplication. And we can also write it using our parentheses, because we know that parentheses with the variable inside next to your number also means multiplication. Okay, so we have 3 different examples of an equation to represent the linear relationship in our graph. All right, make sure that you put this in your journal and bring it with you to class tomorrow. Have a great night.